Here we're asked to solve a nonlinear system. And so to do that, we'll use the substitution method. Now in the first equation, I can isolate 1 over y by subtracting 1 over x on both sides. And that'll leave us with 1 over y equals 4 minus 1 over x. Now if I square both sides, I'll have 1 over y squared equals 4 minus 1 over x, that quantity squared. Now this is what we're going to use to substitute 1 over y squared in the second equation. Doing that, we're left with 1 over x squared plus 1 over y squared we'll use 4 minus 1 over x squared, and that should equal 40. Okay, once we make the substitution step, we can see here we're left with a rational equation with one variable. So we should be able to solve this. Simplifying first, we have 1 over x squared plus 16 minus 8 over x plus 1 over x squared. And that equals 40. That's what we get when we multiply 4 minus 1 over x times itself. Okay, now 1 over x squared plus 1 over x squared is 2 over x squared. And we have 16 minus 8 over x plus 2 over x squared equals 40. And then subtracting 40 on both sides, we get negative 24 minus 8 over x plus 2 over x squared equals 0. Now let's make a quick note that x cannot equal 0 and then multiply both sides by x squared. Doing that will clear the fractions and we're left with negative 24x squared minus 8x plus 2 equals 0. And we have a quadratic equation in standard form. Notice there's a GCF of 2. Let's go ahead and factor out a negative 2 here. That'll leave us with 12x squared plus 4x minus 1. And then the resulting trinomial here factors. Okay, so we have negative 2 times, well, 12x squared factors 2x times 6x. 1 factors as 1 times 1. And so to get a positive 4x, we better put the plus here and the minus there. That'll give us a positive 6x minus a 2x. And then positive 1 times negative 1 is negative 1, and it's factored correctly. And so at this point, we'll set each variable factor equal to 0. 2x plus 1 equals 0, or 6x minus 1 equals 0, and then solve. 2x equals negative 1, or x equals negative 1/2. 6x equals 1, or x equals 1/6. So we got two possible solutions for x, and so since we're solving a nonlinear system, we need to back substitute to find the corresponding y values. Let's use this equation here. 1 over y equals 4 minus 1 over x. And so using x equals negative 1/2, we have 1 over y equals 4 minus 1 over negative 1/2. Or 1 over y equals 4 plus 2. 1 over y equals 6. That tells me 1 over y, that tells me y equals 1 over 6 when x is negative 1/2. Now similarly, 1 over y will equal 4 minus 1 over x when x is 1/6. We'll substitute that in there. And we get 1 over y equals 4 minus 6. 1 over y equals negative 2 tells me when x is 1/6, y then will be negative 1/2. Okay, so now all that's left to do is to present our solutions as ordered pairs. In this case, when x was negative 1/2, the y value was 1/6. And in this case, when x was 1/6, the corresponding y value was negative 1/2. Okay, so the original system has two solutions, and there they are.